to Advent of Code. So we were working on day 15 last video. I'll just close a few things that I opened accidentally. So I'm going to reopen it here because I've actually updated stuff outside Serenity. Wasn't at my usual setup. But yeah, so basically where we had got up to was we could parse the input, and so parsing the input kind of moved into these structures, basically sets of points, and a sensor basically looked after 2 points, the sensor itself and the beacon, and then in the wherever it was, in the main we basically read through all the lines and read a thing. And what I kind of added on to from there was using a similar box type that I'd done in a previous day, which basically has 2 corners, and it's basically like a bounding box around a thing. And so this you can kind of adjust the bounds with another box, and you just basically expand the corners, the 2 corners of the bounding box, and then you can use stuff like width and height and normalize, which is kind of good. So how we do that is we basically go through and get the bounds of the sensor, and that is defined on the sensor, and it basically works out the distance, then going up from the sensor that amount, and you can also go to the left and to the right, so it basically makes a big square around that, and in the middle of that square there'll be a kind of diamond shape. So then we do that, and then I kind of this search box is for part 2, so we can ignore that. Here we basically had to find where row is 2 million, how many positions can't contain a thing. So what we do is we set it to 2000. For the example it's just 10. Again, we can ignore the search box thing, and then we basically make a row, and we use that fill row count, and then we go through that row, and then we see what is empty. So I actually wanted to do where if not row is empty, then we'll count, or something like is not empty. Turns out that just doesn't work in jakt, so we have to do something like box dot width minus count minus 1 just to get it all right. So that's part 1. And you might have also noticed that there's a thing Enum I did, similar to, I think it was actually day 14, that I had that. Yeah, so I had these like, this was like mapping paths, which was sets of points, and the box kind of also did it, and we also had a thing, and it had a 2 byte. So that's kind of what I took it from. And here a thing can either be the sensor of the beacon, or like the mapping of the sensor, like the available space, which means it's unavailable, or it can just be an empty space, and then we got a 2 byte there. The fill row, so I think when I stopped I was just working on the print map. So I went through a couple of iterations here. The first was I tried to just create a big array, like one-dimensional array, but kind of it was going to cover all 2 dimensions. But instead I just go over each row and then build a row with this fill row. So this fill row is new, and I've also got a thing for bolding parts, but that's kind of more applicable in part 2. But yeah, so this fill row, because we're only going after a single row, we need to check whether the sensor is on the same row, and if it is, then we can add in the sensor or the beacon depending on what it is. And then we also need to work out whether that kind of is in the range of the sensor. So to do that, we get the distance of the sensor, then we get like the X of the sensor, so that's where it's like the center point, and then if it is in the range, which I think is potentially a better method for that, but that works. If basically the row we're looking at is in the range of that diamond, then we work out the new kind of we work out which row we are on that diamond shape, and based on that we know how far out from the center we can go. So like in the very center we can go out the same number we are distant from. So the distance is the Manhattan distance to there, so no diagonals doing that. So if we're in the middle we can go fully out, but if we're right at the top we can only go like 0 to either side and just do that. And that basically just fills in whether it is unavailable, if it isn't already something, because we want to keep whether it is a sensor or a beacon, just for pretty printing really. So that is that. And so I got the answer, so what we can do is bust a cache, and that should say, yep, I got the answer. It was quite a big number, but I don't know, you just ran that function. It took around 2 seconds, I think, which to check we would have to do something like this. 1 equals 1, then we can return by 1, return a 0, say. And now if we not that one, tests. Yeah, if we run test, we can kind of see how long it takes to run that, which I haven't actually run inside the VM while I'm recording. It's interesting it failed on that. Yeah, I saw this another time, which is a bit weird, because that's like in bash, this time output. So I thought I did a pull. Improvements to boot, yeah. So we should have outputs. I see why it's failing. Yeah, when we're running it, we're not actually printing the part 2 part of it. But anyway, we can see that the actual input took about 5 seconds, 6 seconds there, just to do part 1. So it is not a quick solution, and it potentially could be quicker, but it did the trick. But now we get on to part 2. So part 2 was basically somewhere inside there'll be a gap, and I think to best show that we'll do this, and maybe we'll run it just over example, and that way we won't get that fail, because it does actually get that answer, but it will also show a map like this, and we bold it. So here we say for the example space, basically x and y have to be at least 0 and no larger than a certain number. So for the actual input it's 4 million, for example it's just 20. So that's basically this highlighted thing, and you'll see in here there's one spot that doesn't have anything there, it's just a dot, and basically you are tasked of finding that. So I've written a brute force solution to this, which basically goes from here and scans and scans and scans and until it gets to this line, and then it's like, oh, there's an empty spot there, that will be the answer. And then you just do like multiply them together or something. Yeah, you multiply x by 4 million, then add the y, which I guess is like how you build up an index like that. Now the problem is this is just too slow for it's too slow for the actual input. So for the actual input, we do the same thing. So basically, we're looping through basically 0 to, like, we set it to 0 up here somewhere. Yeah, we set origin to be 0, 0, and 4 million for the other one. And if it's example, then it's just 20. And here we just go from the origin y to the corner y plus 1, so which is 0 to 20. And we make it inclusive by doing the plus 1. What I would like, maybe I wouldn't, is like maybe a like triple dot to mean like inclusive, or like dot dot equal to show that it's like an inclusive range. But yeah, I'm not too sure. So then we basically have a flag saying whether we found it. We make a row, and here we just make it a smaller search box, so it's only actually going to be filling in these characters. So we won't do extra work on trying to work out all these ones to the side and all these ones and all the ones up the top there. We only get the search box, and so then we send the search box to the filled row, and then we do this X one, which is doing a similar loop on the X's, and then here we basically scan through that to find if there's any empty one, and if there is, it will be there, and it'll know the X and Y, and so we can just go X times 4 million plus Y. We found it, we break, and then we break again out of this one. Some languages have like, you can have like a label type thing like there, and then you break label like that, so you can break out of the full loop. But I am unsure if jakt has that, and like this is not that bad. I did a thing I didn't want to do. Maybe I did want to do that. So that's kind of where I've got up to, and it doesn't run for the actual code. I did some quick math on it, because what I can do is actually, it was here. We could do something like print line row equals that, and just pass in y. And if we go day 15 and build day 15, and the input should still be the same. Here we should see, and we've got a clock down there with some seconds. Oh yeah, that's right. That just doesn't work in the shell. Not sure why, but now if we run this, we should get like row 0. Then what I might do is actually like clear that and like maybe go reset. Sandy, it tells me that. Because the terminal was getting a bit stuffed up there. So we can see here, like, when row 1 happens, it was like 21 seconds, row 2 is 25, so it's around 3 seconds. And we're having to search 4 million rows at 3 seconds each. So that is going to take in the order of like hundreds of days, I believe. So it's pretty slow. It's basically not going to happen like that. Instead, I want to come up with a way to kind of work out where the overlapping things are based purely on like the sensors in the distance, and we can kind of draw, well, we won't actually draw it, but we can kind of form these diamonds in some sort of space, and then kind of overlap all these diamonds on top of each other. And from that, we could probably build it in such a way that the gap will kind of come out naturally, which That's an idea that I need to kind of think on a bit in my head, and come back to it. But for now, I'll just leave this as this. I just wanted to kind of give an update on part 1, I guess, because part 1 is done, and part 2 we'll come back to another time. And if we go back to the main page, so I think if we do some cache busting here, we'll see that we've only got 1 star, and it might be like that for some more days. I don't know, because I'm thinking after this video I'll probably go on to day 16, and just kind of think on this day 15 at the back of my thing. And like, I'm quite behind and I gotta also do work things, so I can't work on this all the time. But for now, hopefully you enjoyed that little summary of part 1 and my kind of thought process on part 2. And until next time, have fun and see you next time for